Hi everyone, I am Swaroop. This is our ACL 2022 presentation on reframing instructional prompts to GPTk's language. This work is done in collaboration with Daniel Kasabi, Chitta Baral, Yajin Choi, and Hana Hajistraji. Instructional paradigm has made NLP modules accessible to non-expert users because they can now provide instructions to accomplish a task by large language models. However, many times these models cannot follow the instructions written by non-expert users. So the question is how to write better instructions. We analyze various instructions and come up with a set of reframing techniques for manual reformulation of instructions into more effective ones, which is evaluated based on an empirical study on a diverse set of tasks. A quick overview of our paper. We wanted to analyze how can a non-expert user write better instructions. We observe important features for successful instructional prompts and propose several reframing techniques to create such prompts. Our results show that reframing notably improves few-shot and zero-shot learning performance across a series of models. We hope that this study will inspire further investigation of potentially unconventional approaches to explore the knowledge harnessed by increasingly large language models. Let's have a look at decomposition reframing, which is one of the reframing techniques we have. Here the task is given a passage. We want the model to generate a question that evaluates one's understanding of pronouns. However, GPT-3 generates a span-based question which doesn't involve understanding of pronouns. And this is how we reframe the task. We first ask the model to generate names of person, places, etc. And then you ask the model to generate a question that contains the name, and similarly we ask model to generate a question from the passage with name as the answer, and finally ask the model to generate a question by concatenating the given two questions. And this is how we make the task easier for models by dividing into a set of simpler tasks. Let's have a look at some other reframing techniques. Here, the instruction is in paragraph form, which is difficult for models to follow. We converted this paragraph form instructions into a bulleted list. We also convert negative instructions into positive instructions, and this improves model performance. This we refer as itemized reframing. Let's see another example. Here, given a passage and a question, the task is to generate the answer type, which can be either number, date, or span. Now for such kind of task, whenever model sees a passage and a question, it ends up generating the answer to the question, even though we ask the model to generate its answer type. So in the reframing, we add an extra line at the end that forces the model to generate the answer type, which is number, date, or span. We refer this as restraining reframing. And similarly, we have other kinds of reframing techniques. In the empirical study, we evaluate across 6 different categories of tasks which are part of natural instructions, that is question generation, answer generation, classification, etc. This is the raw task performance in GPT-3 instruct, and this is the reframed instruction performance with GPT-3 instruct. As you can see, reframing significantly improves few-shot learning performance. We also have another baselines where you allow GPT-3 to have schema selection, and you allow GPT-3 to have as many examples as it can fit within the token size. Now as you can see, even though this baseline uses a large number of examples than what we have in the reframing baseline, still the performance is lower than the reframing baseline. So this implies reframing improves sample complexity. We also have supervised baselines with BART, where you can see that reframing outperforms the supervised baseline in case of answer generation task. However, there is significant gap across other task categories. We also evaluated how reframing on one model transfer to other models. For that, we did reframing on GPT-3 instruct and evaluated other GPT-2 models on this reframed prompts. As you can see, reframing actually significantly improves models across various sizes. We also fine-tune GPT-2 large because you cannot fine-tune GPT-3, and we see that the fine-tuned performance of GPT-2 large is still lower than reframing performance with GPT-3 instruct. This might indicate that reframing prompts on a large model like GPT-3 instruct might be more effective than fine-tuning a smaller model like GPT-2 large with 200x more data. A quick summary of what we studied today. We analyze how can a non-expert user write better instructions. We propose reframing techniques. We find promise in our empirical evidence that reframing improves significantly the few shot performance. Future work will involve investigating potentially unconventional approaches like reframing to exploit the knowledge harnessed by these language models. Thank you.